All right, number 9, we're going to use a change of variables to evaluate the following integral. So here sometimes you want to be a little bit more cautious on trying to figure out what you want to let u equal to. We are taking the integral of secant 10w tan of 10w. And so this is a problem in terms of w. I do recognize that the secant times tan comes from a derivative of, I want to say secant or secant squared, so this is one that's familiar. So we're going to let u equal the inside, the 10w. So if u equals 10w du, derivative of this will just be equal to 10 dw. Don't have a 10 over here besides the argument, so we can't use that one. It's inside of an argument. So 1/10 du will equal to dw. And then we'll use our trig cheat sheet to find the integral of secant tan. So right here, integral secant tan is just secant. Okay, so that is one of those familiar ones. So here we can let u equal the 10w, and then du, which we've done the derivative of u, is 10 dw. That's what they're looking for. And then write the integral using the change of variable, so that will be integral of 1/10, and I can put that out front. Secant u tan u du. They have the du on the outside already. Secant u tan u. And then the integral of secant u tan u was just secant, so we have a 1/10 secant. Now instead of u, we'll put the 10w back, plus c. All right, number 10, again, we want to use a change of variable. So we have integral of secant or sine x, and then we have secant, which comes from 1 over sine. So let's write it like that, because we don't want it to be equal to secant or sine. So let's say, well, would that help us out? Yeah, you want to rewrite this. This is say 1 over cosine is what it is. 1 over cosine. And this is raised to the 10th. And that is drawing out 1 over cosine to the 10th. If you leave it as is, you won't be able to work it out. You won't be able to see that. The reason I'm thinking about that because thinking ahead, and I'm trying to take the derivative so that I can get rid of this sign. And I couldn't do it with secant, so changing it into its basic element. This way, we can now say that, okay, u can be cosine. du, derivative of cosine, is equal to negative sine x dx. Okay, well, now having done that, we have we'll just have a negative, or I can move the negative over, but the sine and dx will give us what's equal to du. We'll just have a negative. Alright, so when we rewrite this, this will be negative 1 over u to the 10th du. And then we can do the power rule. If you think about this as u to the negative 10th, add 1, it'll be a negative 9, divide by that, so we'll have divided by negative 9 and plus c, and we have our negative on the outside, so a negative times a negative ends up being positive, so we'll have 1 over, moving this u to the 9th back down, 1 over 9u to the 9th plus c. And then we can just go back and replace that with cosine. If we want, we can just go ahead and write it as secant, so we can write secant to the 9th divided by 9. However we want to write it, it should work out. I'm going to write it as 1 over cosine just to see if it says it's equal to the correct answer, but maybe not in the right form since we rewrote it. Cosine of x raised to the 9th plus c. Let's just see. They'll take it in that form as well. So you can write it like that, or you can write it as secant, and it will take it